We've already been studying how to solve triangles. We've looked at using SOHCAHTOA. The drawback with SOHCAHTOA is that it only works with right triangles. So what happens if we want to know information about a non-right triangle? We're going to have two main ways of finding that, and that's going to be the law of sines and the law of cosines. The law of sines is going to be a proportion. We can choose any angle and side we want. We're always going to choose an angle and its opposite side. We're going to use those to make a ratio and set it equal to another angle and its opposite side. I could do sine of A over A is equal to sine of C over C. I could do sine of A over A is equal to sine of B over B, or sine of B over B is equal to sine of C over C. I'm always going to have A and A across from each other, B and B across from each other, and C across from each other, as you can see in this visual representation here. So angle A, also referred to often as angle alpha, and A are opposite. Angle B or beta, and B, angle C or gamma, is across from C. The law of sines is going to always be used with angle, angle, side, angle, and side, side, angle. We will look at this side, side, angle situation in class together. We're going to focus in this video and in the practice that corresponds with it on angle, angle, side, and angle, side, angle. I personally don't like to memorize when I use law of sines. Instead, I just like to always first try to set up a proportion, and if that fails, then I fall back on law of cosines as opposed to memorizing which triangles it works with. So let's go ahead, and there's two examples. So let's go through the first one together. So first thing I always do is I always draw my triangle first, and I label everything I know. So I'm going to go ahead and call this triangle A, B, C, and I know A is 63 degrees, B is 51 degrees, and A is 13. So I can see right here I have an angle and its opposite side, so I'm going to go ahead and right away say that sine of 63 over A is equal to, and if I look at what I need to find, just like before, we're going to find everything that we don't have. So I notice I'm going to have to find out what is B, what is gamma or angle C, and then also what is little c. So if I go ahead and record what I need to find, I've got a proportion here to help me solve for angle A, or excuse me, side length A. Oh, and I know what side length A is, so I can go ahead and I can replace that A with 13. So sine of 63 over 13 equals, since if I use gamma and C, I'll have two unknowns, I'm going to go ahead and choose 51 and B, and say sine of 51 over B. And now I'm going to use cross multiplying, since I have a proportion equal to a proportion, and I'll have B times sine of 63 equals 13 times sine of 51, and I'll divide by sine of 63 to get B by itself. From here, I check to make sure my calculator is in degrees. I put this into my calculator and I get an answer of 11.339, as always rounding to 3 decimals. So that was my B, so I'm just going to fill that in over here. And now I see I need to find angle C and side C. I can find angle C by subtracting 63 and 51 from 180, so I'm going to go ahead and do that. And that gives me my angle C value of 66. So gamma is 66 degrees. And all I'm left to do is find C. So I'm going to go ahead and take 63 and 13. And I now know that this is 66. So I'm going to take 66 and C and set up a proportion. So sine of 63 over 13 is equal to sine of 66, my found value of angle C, over C. And once again, I have a proportion equal to a proportion, so I cross multiply. And then in order to get C by itself, I can divide both sides by sine of 63, giving me a C value of, putting this into my calculator, once again making sure I'm in degrees and entering that in my calculator, I get a C value of approximately 13.329. And I have now found all of my missing pieces of my given triangle, so I have therefore solved the following triangle, or solved for my triangle. I'm going to go ahead and look at an second example with this. There are only 2 examples on this video, so if you'd like to try one, the second one's a great one to try. But just like before, I'm going to start by drawing my triangle. So A, B, C, and labeling what I know. I know B is 29 degrees. I know that little b, which is always going to be across from big B, is 18. And I know that C is 25 degrees. So again, what do I have to find? I notice I have to find my angle A, my alpha, my side A, and my side C. So in order to stay organized, I always write down what I need. So I need alpha, I need A, and I need C. Since I already know 2 of my angles, my alpha is pretty basic to solve for. I can just take 180 minus 25 minus 29. That'll give me my alpha, which is 126 degrees. And now from here I can solve for either A or C. I'm going to go ahead and use B and 18 since I know both of those. Sine of 29 over 18 equals, if I go ahead and solve for C, since I already know angle C, I can say sine of 25 over C. I have a proportion, so I cross multiply. And in order to get C by itself, I divide by sine of 29 on both sides. I'll go ahead and put that step in. And again, my calculator knows order of operations. So in order to solve for C, I put that into my calculator, once again making sure I'm in degrees, and I get a C value of 15.691. And 691, and then I just need to go back and solve for A. So again, I'm going to use 29 and 18. I could use 25 and that 15.691 if I wanted to. And then I'm trying to solve for side A. I know my alpha, I've already solved for that, is 126. And I can again cross multiply. I'll divide by sine of 129 and I get A equals 18 times sine of 126 all over, I don't know where that 1 came from, it's just 29, sine of 29, and then I put that into my calculator and I get an A value of approximately 30.3.037. And I have now solved for everything I need to successfully solve for my right triangle. So law of sines used whenever we can set up 2 proportions, and after setting up those 2 proportions, I only have 1 unknown to solve for. I can also use the concept that there's 180 degrees in a triangle to solve for that missing angle if I'm only missing 1. So that is going to be your law of sines.